Hello, in this lecture we will find the area of the yellow circle. Actually, we have in the picture semicircle, and the center of the semicircle is at point O, and the touching point between the yellow circle and the semicircle is at point P. And also we know that PQ equals to 7 times root 2, and OQ is tangent to the yellow circle at point O, and actually the formula of the area of any circle, I will call the area A. So the area of any circle equals to pi times the r square. R is the radius of the circle. So actually, in order to find the area of the yellow circle, we only have to find the radius of the yellow circle, and from the radius we will know the area, because the area equals to pi times the radius square. Okay, so let's call the center of the yellow circle M, and let's join points O and M together. Actually, OM is the radius of the yellow circle because it starts from the center of the yellow circle, that is to say from point M, and ends at point O, that is a point on this yellow circle itself. So this is actually the definition of a radius. Any radius of a circle starts from the center of the circle and ends at any point on the circle. So in this picture we have the line segment MO that starts from the center of the yellow circle, that is to say from point M, and ends at a point on the yellow circle itself, at point O. So MO is defined as the radius of the circle. Let's call it R, small r, and actually we have rule number 1 that states that if two circles touch each other, internally or externally, Then the point of contact lies on the straight line joining their centers. So I will read rule number 1 again. Rule number 1 states that if two circles touch each other, either internally or externally, then the point of contact lies on the straight line joining their centers. Now I will explain the meaning of rule number 1 on our drawing. The yellow circle touches the semicircle at point P. So point P is the point of contact, and according to rule number 1, the point of contact lies on the straight line joining their centers. So point P lies on a straight line that joins the two centers together. So actually PMO is a straight line, because according to rule number 1, the point of contact, that is to say point P, lies on the straight line. Which straight line? On the straight line that joins the two centers together. So point P creates with the two centers a straight line. That is to say, PMO is a straight line. Okay? I will repeat again. If two circles touch each other, internally or externally, those two circles, the yellow circle touches the semicircle internally, then the point of contact, that is to say point P, lies on the straight line joining their centers. That is to say, point P lies on straight line. Yes? Rule number 1 says that point P lies on a straight line. Which straight line? The straight line that joins the centers together. That is to say, line PMO is a straight line. Okay? Because according to rule number 1, point P lies on a straight line, on the straight line. Which straight line? The straight line that joins the two centers together, and the two centers are M and O. M is the center of the yellow circle, and O is the center of the semicircle. So the line that joins the 2 points, the 2 centers together, is a line segment, and according to rule number 1, point P also lies on that straight line. That is to say, PMO is a straight line. Okay? Again, if two circles touch each other, in our case, those two circles touch each other internally. The yellow circle touches the semicircle internally at point P, and point P is called point of contact. And this point of contact lies on straight line. Which straight line? On straight line that joins the centers together. So actually, that is to say, PMO is a straight line, because point P lies on straight line, on the straight line that joins the centers together. That is to say, PMO is a straight line. Or in other words, we can say that PO is a straight line. Okay? PO, according to rule number 1, PO is a straight line. PO is a straight line because point P lies on a straight line that joins the two centers together. So PMO is a straight line, that is to say PO is a straight line. So PO is a straight line. But MO is the radius of the yellow circle, and MP is also the radius of the yellow circle, because MP, line segment MP, starts from the center of the yellow circle and ends at point P, that is a point on the yellow circle. Therefore, it is defined as the radius of the yellow circle. So actually, we have two radiuses of the semicircle on a straight line. Therefore, we can also define OP as the diameter of the yellow circle. So OP or PO is the diameter of the yellow circle. Okay, I will read again what I wrote. PO is a straight line, and PO is the diameter of the yellow circle, because PO equals to 2R. and the diameter is defined as two radiuses. Okay, but because of the fact that PO is a straight line and it also exits from the center of the semicircle, so PO exits from the center of the semicircle and ends at point P, that is a point on the semicircle. For that, therefore, PO is also the radius of the semicircle. So I will mark it as capital R. PO is the radius of the semicircle. I will mark it as capital R. So again, because of the fact that PO exits from the center of the semicircle and ends at a point on the circle or the semicircle, because of that fact it is considered as the radius of the semicircle, so I marked it as capital R. And as you can see, we have the relationship between capital R to the small r. As you can see from the picture, capital R equals to 2 times R. Or you can also okay, you can see from the picture that capital R equals to 2 times R. Or you can also deduce that capital R equals to 2 times R from the fact that OP from one side equals to 2 times R, because OP is the diameter of the yellow circle. Okay, that is from one side. From the other side, OP equals also to the radius of the semicircle. OP equals to capital R. So from equation 1 and 2 you can deduce that R equals capital R equals to 2 times R. Okay? So we can deduce from equation 1 and 2 that capital R equals to 2 times small r. Okay, so we will call this equation equation 1. Equation 1 states that capital R equals to 2 times small r. Okay? And actually we have the second rule. The second rule states that rule number 2, rule number 2 states that in any circle a radius and the tangent to that radius are perpendiculars to each other. Are perpendicular to each other. So I will read rule number 2 again. Rule number 2 states that in any circle, a radius and the tangent to that radius are perpendicular to each other. So actually, if we have a radius, let's call it R, and if we have tangent to that radius, let's call it T, then the radius is perpendicular to the tangent. That is to say, this angle equals to 90 degrees, and also this angle equals to 90 degrees. Again, in any circle, a radius and the tangent to that radius are perpendicular to each other. This angle is 90 degrees, and this angle also is 90 degrees. So, actually, we can implement rule number 2 in our circles, because we have segment MO, that is the radius of the yellow circle, and we have tangent QO to that radius, and according to rule number 2, they are perpendicular to each other. That is to say, MO is perpendicular, the radius is perpendicular to OQ. That is to say, this angle equals to 90 degrees, or angle POQ equals to 90 degrees. And also this angle, let's call it L, angle POL also equals to 90 degrees. Okay? So again, in any circle, a radius and the tangent to the radius are perpendicular to each other, and for that reason angle POQ equals to 90 degrees, and also angle POL equals to 90 degrees. Okay, so now we will focus on the right triangle POQ. POQ is a right triangle because angle POQ equals to 90 degrees. Okay? Before that, OQ is the radius of the semicircle, because it starts from the center of the semicircle and ends at point Q, that is a point on the semicircle itself. Therefore, it is defined as the radius of the semicircle. I will call it capital R. So actually we have side OQ of the right triangle POQ, that is R, and also we have side PO, that is also R, capital R, and we also know that the hypotenuse of this right triangle equals to 7 times root 2. Okay, so I will draw again the right triangle POQ. And we actually will implement the Pythagorean theorem on this right triangle in order to find out the value of capital R. Okay? So actually we have angle PO. So I draw again the right triangle POQ. As you can see in the drawing, PO equals to capital R, OQ equals to capital R also, and the hypotenuse of the right triangle POQ equals to 7 times root 2. As you can see, it is exactly the same as the original drawing. Okay, angle POQ is equals to 90 degrees. So actually I will repeat on the Pythagorean theorem, although that I assume that you have already know what it states, but I will repeat it on it again. So the Pythagorean theorem states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. I'll read it again. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say the square of the hypotenuse in the right triangle, and it is correct only in the right triangles. So I can add to the Pythagorean theorem that it relates only to right triangles. Okay, I add that it relates only to right triangles. Okay, I added it here. It relates only to right triangles. So actually, in our right triangle POQ, the square of the hypotenuse is actually PQ square equals to the sum of the squares of the perpendiculars. That is to say, it equals to PO square plus OQ square. Okay, so according to the Pythagorean theorem, PQ square equals to PO square plus OQ square. But we know that PQ equals to 7 times root 2, so I will substitute PQ by 7 times root 2. Equals to PO square, but we know that PO equals to R, so we can substitute PO by R. So 7 times root 2 square equals to R square plus PQ square plus OQ square. But we know that OQ equals to R, so we can substitute OQ by R. So it will be R square. So we got that 7 root 2 square, that is PQ square, equals to PO square, that is R square, because PO equals to R, and OQ square is R square because OQ also equals to R. Okay, so 7 times root 2 square equals to 49 times 2, it equals to 2 times R square. Okay, 7 times root 2 square is actually 7 square. 7 square is 49. And root 2 square equals to 2. And R square plus R square equals to 2 times R square. Now we can divide the equation by 2. We will get that so after we divided the equation by 2, we got that 49 equals to R square, because 2R square divided by 2 equals to R square, and 49 times 2 divided by 2 equals to 49. Now we will take out root from this equality. We will get that the root of 49 equals to r. Okay, the root of r squared is r, and the root of 49 equals to 7. So capital R equals to 7 units. The 49 has two roots. 49 has the first root is 7, and the second root of 49 is -7, but because we are dealing with the radius, it must be a positive number, so we take into account only the root of positive 7 and not the negative 7. So we got that the radius of the semicircle, that is to say capital R, equals to 7 units. But according, so we'll call it question number 2, but according to equation number 1, we know that, according to equation number 1, we know that capital R equals to 2 times small r. Okay, so we can actually add equation number 1 here. Capital R equals to 2 times small r. Okay, this is equation number 1. Capital R equals to 2 times small r. But we know that capital R equals to 7. So we can substitute capital R by 7. So here we add that R, capital R equals to 2 times small r. We know that R equals to 7, so we can substitute capital R by 7. We substituted capital R by 7, so we got that 7 equals to 2 times small r. We can divide the equation by 2, so we will get that small r equals to 3.5 units. Okay, we got that small r equals to 3.5 units because 7 divided by 2 equals to 3.5, and we have the equation or the formula for the area of a circle. The area of any circle equals to pi times r squared. The area of any circle equals to pi times r squared. R is the radius of the circle, but we know that the radius equals to 3.5 units, so we can substitute r by 3.5 units. So we will get that the area of the yellow circle will be equal to pi times 3.5 squared. Okay, we substituted r by 3.5. We got that the area of the yellow circle equals to 3.5 squared times pi. The value of 3.5 squared is 12.25. So the area equals to pi times 12.25. Okay, the value of 2 times 3.5 squared is 12.25, and the pi times 12.25 equals to 38.48 units. Okay, so the area of the yellow circle is 48. The area of the yellow circle equals to 38.48 units. As you can see here, we actually got that the small r equals to 3.5 units, and we substituted in the formula of the area of a square, that is a equals to pi r square. We substituted r by 3.5 units, and we got that the area of the yellow circle equals to 38.48 units. Okay, so that is the answer to our question. And now I will summarize the lecture. So actually we wanted to find out the value of the area of the yellow circle, and in order to find the area of the yellow circle, we have the equation of the formula of the area of any circle equals to the area. The formula is that the area equals to pi times the radius square. So the only thing that we need to find is the value of the radius of this yellow circle. Okay, so we know that we have here a semicircle, and the center of the semicircle is at point O, and actually point P is the touching point of the yellow circle with the semicircle, and we know that line segment PQ equals to 7 times root 2, and we actually connected, we defined that the center of the yellow circle will be named as M, and we connected points M and O together. MO actually is the radius of the circle, and also actually we have rule number 1 that states that if two circles touch each other internally or externally, then the point of contact lies on the straight line joining their centers. So according to rule number 1, if two circles touch each other, in our example, the yellow circle touch the semicircle internally, then the point of contact, that is to say point P, lies on the straight line joining their centers. So point P lies on a straight line, and on which straight line point P lies? On the straight line that connects the two centers together. The two centers are M and O. M is the center of the yellow circle, and O is the center of the semicircle. So according to rule number 1, P, the point of contact, lies on a straight line that includes the two centers. That is to say, PMO is a straight line. Okay? According to the rule number 1, the point of contact, that is to say P, lies on the straight line joining the centers. So the line that joins the two centers together is actually point P creates with the line segments that connects the two centers together a straight line. That is to say, PMO is a straight line. Therefore, PO is also a straight line. And actually, PO is actually the diameter of the yellow circle, because MP is also a radius of the yellow circle because of the fact that it exits from the center of the yellow circle, and it ends at point P, that is a point on the yellow circle. For that is exactly the definition of a radius. For that reason, MP is also the radius of the semicircle. So we know that actually OP equals to 2 small r's. That is to say, OP is the diameter of the yellow circle. But because of the fact that OP is also a straight line, according to rule number 1, we can deduce from it that OP is also the radius of the semicircle, because it exits from the center of the semicircle and ends at point P, that is point on the semicircle itself. For that reason, OP is defined as the radius of the semicircle. So we called it capital R. And we can see from from one side we know that OP equals to 2 R, 2 small r's. And from the other side, we know that OP also equals to capital R, the radius of the semicircle. So from that we can deduce that capital R equals to 2 small r's. Okay? And we also have rule number 2 that states that in any circle, a radius and the tangent to that radius are perpendicular to each other. So actually, if we have a radius that its name is R, and the tangent, we call it T, then the radius is perpendicular to the tangent. That is to say, this angle is 90 degrees and also this angle is 90 degrees. So we can actually use rule number 2 in our two circles, so we can implement rule number 2 in our two circles, because MO is the radius of the yellow circle and QO is a tangent to that radius. For that reason, they are perpendicular to each other according to rule number 2. So angle POQ equals to 90 degrees. And also we know that OQ is also the radius of the semicircle, because it starts from the center of the semicircle and ends at point Q, that is a point on the semicircle itself. So for that reason, OQ is also the radius of the semicircle. So we actually have a right triangle with side OP that equals to the radius of the semicircle, side OQ that equals to also the radius of the semicircle, and the hypotenuse of this right triangle PQ equals to 7 times root 2. So we actually can implement the Pythagorean theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, and it relates only to right triangles. That is to say, actually, that PQ square equals to PO square plus OQ square, or 7 times root 2 square plus equals to R square plus R square. Okay, so, and we got to the answer that capital R equals to 7, but we know that capital R equals to 2 times small r. And we found out that capital R equals to 7. So we got that the small r equals to 3.5 units, and we can put that r in the formula of the area of a circle. And the formula of the area of the circle is pi times r squared. We can substitute r by 3.5 units. That is the radius of the yellow circle. And in that way we will find the value of the radius of we will find the area of the yellow circle that we call it A. So at the end we got that the area of the yellow circle equals to 38.48 units, because we put it in the equation pi r squared, pi times 3.5 square equals to 38.48 units. So the area of the yellow circle equals to 38.48 units. Okay, thank you very much.